So I think you all can hear my voice, right? Hello. Okay. Okay, so like yesterday we discussed some things related to probability, and specifically in this lecture we'll also discuss some more things. And the thing is that actually making the slides is slightly difficult because of the lot of notation. So that's why I just brought my written notes, and I will just share these notes with you. You can just use it for your own purpose. Okay, so. Yesterday we talked about a lot of things related to probability and obviously conditional probability and multiplication theorem we saw. But in this we also see some examples related to those all things. Okay, so there's no need to worry about it. So just let me start with the something called exhaustive event. Okay, so these things will be actually be very useful in specifically finding the total probability and Bayes theorem. And like in probability, Bayes theorem is the most important thing because there is a lot of questions framed based on the Bayes theorem. Not now only when you go to the college and you will give test for placement, you'll also there you also find a lot of questions related to Bayes theorem. So Bayes theorem is the most popular thing in the probability. So exhaustive event. Let's say you have n event. Okay, so let's say you have n events from E1 to En. Okay, so a set of events is said to be exhaustive if the union you take, you will find the set S. So it means that if you take the union of the set, you take E1 union E2 union En, you will get your original set. Original set means your sample space. So if you just see this thing with example, so let's say you are throwing a die. Okay, you are throwing a dice, and in that particular thing, let's say your event A1 is the set of all even numbers. So even number is 2, 4, 6, and A2 is the set of all odd numbers. So it is 1, 3, 5. Okay, so here you can see that if you take the union of these two event A1 union E2, you will find the original this your original what you can say original sample space. Okay, so this is what the definition of exhaustive event is. It's not with the one event. So let's say we also define A3 to be some set with number 1 and 3. In that case also, if you take the subset, you will get that only your sample space. So any number of set you have, it may be some of the events may have some repeating element, but the thing is that when you take the union, you will get the original set S, or you can say it's your sample space. So this thing is called the exhaustive event. Exhaustive means every event together can, when combined together, will be your sample space. That's why this is called an exhaustive event. And this particular thing is very much useful when you are especially trying to study the Bayes theorem and total probability. Okay, so simple thing, exhaustive event is only the just take the whatever the your events have, just take the union of those events, and if you get to your sample space, this is called exhaustive event. There is something called mutually exclusive and exhaustive. Okay, so mutually exclusive and exhaustive have two conditions to satisfy. So these two conditions are, let's say again you have just n events E1 to En, and E1 to En you have event, and you are having this first condition is the similar to the last one. Just take the union of all those events, and you are getting to the your original set S. Okay, and once these are the both conditions simultaneously should be true. And the second condition is that when you take intersection of all those element, all those event, you will get a null set. Means none of the elements are actually common in all those together. So it means that key for any events to be mutually exclusive, the overall thing is to be either it should have means both conditions should be true. First one is that when you take the union of all those events, it is the your sample space, and when you take the intersection of all these events, it's a null set. So like here you can also show that let's say we define something like this in throwing of dice. A1 is this, A2 is 3, 6, and A3 is your 4, 5. Okay, so here you can see that if you take the union of all those events, you will get the sample space S. Okay, but if you take the intersection, you will get 5 because none of the elements are common in any of the set. So in this case, you will see that this thing is actually mutually exclusive and exhaustive event. So I mean, so this way you can think of exhaustive event and mutually exclusive and exhaustive event. So whenever base theorem, I will just introduce, and then you will see that how these things are being used in the base theorem. So do anyone of have problem in understanding what is the exhaustive event and what are the mutually exclusive and exhaustive event? Anyone, if it's okay, then I will move ahead. Guys, is it okay? Okay, so yesterday I introduced some of the concept related to especially the union of two event and intersection of two event. But like in general, there are some rules. So let me just state every rules because that will actually help you understand and solve a lot of questions. And like these rules, you should remember. You could say that these rules you should keep in mind while solving the questions from probability. So if there is something being asked as simultaneous occurrence of both event A and B. So it may be given at questions like there are two event A and B. So find the probability of simultaneous occurrence of both events A and B. In that case, it is talking about A intersection B, because A intersection B actually means this thing. So I'm just stating like whatever when particular thing is asked, whatever it want to say in terms of probability or set. So if it's talking about simultaneous occurrence of both events A and B, it is talking about probability of A intersection B. Okay. So if it's talking about occurrence of at least one of the event A and B, it's saying simultaneous occurrence, and here it is saying at least one of the event, occurrence of at least one event means either A occurs or either B occurs or A intersection B means both occurs. So in that case, it is talking about A union B, probability of A union B. Similarly, if it's talking about not occurrence of event A, it means it is talking about probability of non-occurrence of A means A complement. Okay, so these things will be actually very much useful when you will see some questions, and when the things are written in the word, things are not written in the symbol. So it may like it may be given at just find the probability of A intersection B, or it may write it just find the probability of simultaneous occurrence of both event A and B. Then in that case, you should understand that it is talking about probability of A intersection B. Similarly, this thing A intersection B complement, it denotes that occurrence of event A but not B. So A intersection B complement means A is occurring but B is not occurring. That's why its intersection, its complement has been taken. Okay, what about this A complement intersection B complement? Simply it means that neither A nor B occurs. Okay, neither A nor B occurs. So it can also be represented by this way as we saw yesterday. And this thing is theorem you all pointed out. So De Morgan's theorem. So this particular thing is that A intersection in A complement intersection B complement means neither A occurs nor B occurs. Okay, A union B union C means occurrence of at least one of A, B, or C. So either A occurs, either B occurs, or either C occurs, or A or B occurs, A or C occurs, or B or C occurs, or A, B, or C both. So it's all about the everything that is combinations of that combination of event that can possible out of this three event. So A union B union C means occurrence of at least one event means it is sure that at least one event is occurring. So some will find questions like that. Means I'll just show you some example also. It's talking about occurrence of at least one of A, B, or C. So like the yesterday I give you an example of the particular engine problem. So like that particular problem can also be thought like this way. Okay, so the problem is you have three engines. Okay, E1, E2, and E3, and this particularly engines, this particular system will work if either of this particular engine work. Either means at least one of these engines should work. In that case, it may exclusively give that probability of E1 is equal to maybe say 0.2. Here it is 0.3. Here it is 0.5. And similarly, it can give all the probability. And similarly, you can use this formula to find the probability of occurrence of A, B, or C. So it means that if somewhere it's talking about occurrence of at least one event of A, B, or C, at least one event means it may occur that some two events are also occurring, three events can also possible. Maybe B and C can occur together also means any possibility can be there, but at least one event is occurring. In that case, you have to use this particular thing of A union B union C. Okay, in next case, A intersection B complement union A complement intersection B. So this particular thing, first part is showing that A is occurring but B is not occurring, and this part is saying that A is not occurring but B is happening. So it means that you will find a probability. It means that occurrence of exactly one of A and B. So in this case, exactly A is occurring, and in that case, exactly B is occurring. It's not talking about A intersection B. Okay, it is not talking about this particular thing. So if you are, if we find some questions related to occurrence of at exactly one of A, B, or C, sorry, A or B, then you can, in that case, you can exactly use this particular formula. And like, I'm not talking about the proof, because at this point of time, proof can be time consuming and anything. But if it's talking about how to find the probability of exactly one of A and B, so in that case, you need to find this particular probability. So probability of A intersection B complement union B A intersection A complement intersection B. This particular thing. A intersection B intersection C means occurrence of all three events simultaneously. Okay, simultaneously. So this particular thing is there, and it's talking about occurrence of all the events simultaneously. So this is exactly the same as A intersection B. You know, like there are four events, you can just compare the same thing this way. Okay, another thing is that A intersection B intersection C complement, and again repeating the same thing with union over other elements. So here now here B intersection is taken and here A intersection is taken. So it's talking about A and B are occurring. Okay, A and B are occurring, but C is not occurring. Here also A and C are occurring, but B is not occurring, and here B and C are simultaneously occurring, but A is not occurring. So in that case, it is talking about exactly two of the event A, B, and C are happening. Exactly two of event. So either A and B occur, either B and C occur, or either A and C occur. So these nine formula actually will help you to find a lot of probabilities. Obviously, like all the times it will give like some two events are occurring, or either occurring of event or that one, or some word problem will be there. So word problem or anything written in the words, you can translate it into the set and the probability using these particular things. Okay. So is there any questions or any doubt, or is it clear? Anyone? Okay, yesterday I also pointed out something related to independent event. Like if E1 and E2 are independent event, then E1 and E2 complement. E1 complement are also independent. E1 complement E2 are also independent, and E1 complement and E2 complement are also independent. So like sometimes it may be written that you have probability of E1 means it is given that E1 and E2 probability is given, and E1 and E2 are independent. Then you have to do some calculations to find out maybe some this probability or some combinations of this probability. And just one thing that you need to remember it as, just if E1 and E2 are independent, then all possible combinations of their complement are also independent. Okay, so this result I also always already pointed out tomorrow. And so at this point of time, like we can see some example. So example is for a post. So let's say this is a example of three events simultaneously. So let's say for a post, three person A, B, C are appearing in the interview. So this is a word problem. The probability of A being selected is twice that of B, and probability of B being selected is twice that of C. So what are the individual probability of A, B, and C? So we need to find out probability of A, probability of B, and probability of C here. Okay. So in this case, just let's write something like how you can present this problem, the proper solution. So let E1, E2, and E3 be the event of selection of A, B, and C. So like we are representing a selection of A as the E1, B as the E2, and three C as the E3. So in that case, we know that let's suppose probability of B3 is X, because exactly we don't know the probability of any events. Okay, so it's written that probability of A being selected is twice that of B, and probability of B being selected is thrice that of C. So when we assume that probability of C is X, then in that case probability of B being selected is 3X. Okay, and the probability of A being selected is 2 times probability of B, which is 6X. Okay, so these probability all we assume. Okay, now the thing is that E1, E2, E3 are mutually exclusive and exhaustive event, and anyone can say that how this thing is possible. Okay, so like just think it this way by the definitions only. Okay, if you have all those three bent, then like this particularly E1, E2, and E3. So this thing is that you can just assume that means these three things are actually not part of this means what you can say if E1 is selected. E2 is selected and E3 is selected, it exactly covers the whole universe. Okay, so because in the sample space in the universe that the problem is talking about, there are only three people. So if you just take the union of all this particular thing, and then it means that we were talking about the whole particular subset, whole particular set, because there are only three people only. So like it may have that four people are there, and we are talking about three people, selection of three people. In that case, it could not have been mutually exclusive event, because in that case you should have talked about the fourth people also. But it means that here there are only three people, there are only three people, and we're talking about like probability of everything they have. So in that case, it will be a mutually exclusive event. Okay. Also, like this is also a exhaustive event, and you can just say that E1 intersection E2, what it is means probability of a simultaneous occurrence of E1 and E2. So it's exactly saying that for a post means there can be exactly one person there. So it is already zero because both cannot be selected. Okay, because there is only one post there. So probability of what is occurring of E2 intersection E3. This is also zero because there is only one person. Both cannot be selected. So these things is already excluded. Okay, so in that case we can see that if you apply this particular formula, if you apply this particular formula of A intersection A union B union C. So in the last class we saw that A union B union C the formula. In that case we have probability of this particular thing, the summation, and then plus minus probability of E1 intersection E2, and all the combinations of this thing, and then at the end plus probability of E1 intersection E2 intersection E3. Okay, so we saw that this particular thing is already excluded because there is only one post. The question itself is about only one post, a post, and we can't select two-person together. So this probability is it's not a part of the problem. So these things are already included. So we are left with just the summation part because these things are already zero. And since this is a mutually exclusive event because it's talking about the obviously all the three-person, so its summation is going to be one. So in that case, you just need to add the individual probability, which is x, 3x, and 6x, and you get x as the 1 by 10. So if you get x as 1 by 10, you can easily calculate the probability of E1, E2, and E3. So this is how this problem can be solved. Okay. So do you have any questions or any doubt regarding this question? Anyone? Okay, so okay, and now let's just move to the next problem. So next problem is about some typical application of quadratic equation and probability. So it's saying that A and B are the independent event, okay, and probability that both A and B occurs is 1 by 8. So both A and B occurs. I already told you that if simultaneous occurrence of both A and B is counted, it's talking about probability of A intersection B. And in next case, probability that none of them occurs. None of them occurs means neither A occurs nor B occurs. So in that case, we are talking about this particular thing. Obviously, this particular thing. Okay, occurrence of neither A nor B. So it's saying that if both the probability is given. This is 3 by 8, and the occurrence together is 1 by 8. Then find the probability of occurrence of A. So A and B are two independent events. Probability that both A and B occurs is 1 by 8, and neither of them occurs is 3 by 8. So let's just write this into the mathematical notation. So probability that A intersection B, because this is talking about the occurrence of both them together, it's 1 by 8. And obviously both are independent, so we can write it using this way. Okay, so this is just because A and B are independent. Obviously, then the next thing is both of neither of occurrence together is 3 by 8. So this particular thing we're talking about, and we can also write them in the this thing because A and B are independent, and this particular formula, this particular result follow the same. Okay. Now we can easily break this particular thing into different types. So like PA can be break as 1 minus PA because we already saw that the probability of occurring of A and probability of not occurring of A, both probabilities simultaneously is equal to 1. Okay, and same we can break this two part, and this we can multiply these two part. So when we multiply these two part, we get that 1 minus PA minus PB plus PA into PB is equal to 3 by 8. So in this case, we get PA plus PB is equal to 3 by 4 by solving this particular thing, doing there and there, and this particular thing is replaced as 1 by 8. Now at this point of time, we have two things. We has summation of P and PB, and we has product of P and PB as 1 by 8, and it's 3 by 4. The thing is that in quadratic equation, there is something called summation of root and product of root. Okay, sum of root and product of root. So if you have given sum of two root and product of two root, then in that case you can form a quadratic equation. So it's saying that the quadratic equation whose roots are p and pb, actually it is given by x square minus summation of root, okay, summation of root and plus product of root, and it is equal to 0. So this is the quadratic equation. Actually, you get this thing. So summation of root means if p and pb are the root, then summation of root means 3 by 4. It's already given, and product of root 1 by 8 is also given. So you can just replace these two things in this particular formula, and you get this particular quadratic equation. And when you solve this particular quadratic equation, what you will get? You will get your roots only. Okay, so when you solve this particular equation, you get 1 by 2 or 1 by 4, and these are the roots of this particular quadratic equation. So root means it's a pa and pb. Okay, so it means that PA either will be 1 by 2, then in that case PB will be 1 by 4. And if you assume that PB is 1 by 2, then in that case PA is 1 by 4. So we can say that PA can be 1 by 2 or 1 by 4. So in this particular case, there can be multiple correct questions given, and there will be four options. Okay, and it will ask about the maybe the value of A, the probability of A, and you know, like in two options, it will be 1 by 2, 1 by 6, 1 by 4, or 1 by 8. And in particular case, you need to solve these particular questions to see like what are the correct answer to this question. So, is this thing clear? Like, means, are you aware about this particular quadratic equation formula, sum of the root and product of the root? Like, if the sum of the root and product of the root is given, then how to form the quadratic equation? Anyone? Okay. So, like, especially this quadratic equation is the important thing, because, like, these type of questions are formed a lot, because it just need, maybe you can use some concept from probability, maybe you can sometimes you can use some concept from permutation and combinations, and it can be translated into quadratic equation questions. And in that particular case, if you're just not aware about this particular thing, then you will get to a point and then you're stuck there. So, obviously quadratic equation is important. PNC I already told it's important. And like, we'll touch some topic of quadratic equation, permutation combination matrices also after completing this particular thing. And you will also see some interrelated questions like probability plus permutation combination plus quadratic equation. These are questions we will also see. Okay, so these things actually, means, this type of questions is actually, like, where some thinking skills required. And just if these things are asked in the subjective section, just try to follow this type of answer, like everything is step by step. Why this particular thing is there, just write the name of the theorem. And like in exclusively in 12th board, if you have from the science background, in the 12th board, the way you have explained the answers in the 12th board, just write the same way, because this is how actually explanation goes. And in the BSc, in the BTech also, when there was a math class, you should have explained the answer same way to get the full marks. So in the subjective part, you need to explain the things to get the full marks, and this is the way. Just write everything step by step, like why this particular thing is coming from, where this particular thing is coming from, everything is step by step. Okay, because obviously the person who is checking the answer, he knows everything, but you should be presenting your answer so well that he knows that you are also aware about these things. Okay, so, okay, this was the problem. Okay, and one more problem let us discuss, and then we'll move to the total probability theorem. So the particular question is, in a class 30% students fail in the particular subject, English, 20% fails in the Hindi, and 10% student fail in the both. So just let's, if you just talk about the problem. A student chosen at random, what is the probability that he will fail in the English if he has failed in Hindi? So he has already failed in Hindi. Then it's talking about what is the probability he will also fail in the English. So this is a conditional probability question. And in this particular case, the thing is that, like S is a sample space, you can assume. And like whenever the percentage questions are given, you can also calculate the probability using something by translating in terms of 100, or you can directly assume the probability. Okay, so let's say E1 is the event of failing in English, and E2 is the event of failing in Hindi. So probability of E1 is, so it's given that only 30% student fail in English. So just you can assume 0.3. Okay, so 0.3 you can already assume. Probability of this Hindi particular thing is 0.2. That's why you can either assume this particular thing, and or you can also calculate within 100 and you get the same answer. So let's say 100 student are there, 30% student fail in English, so the probability is 30 by 100. Okay, so this is the same thing, 0.3. Okay, so same thing you can calculate by the assuming the number also. You can just assume the percentage itself into a probability. So it's saying that both the 10% of students fail in both the subject English and Hindi. So it's given at probability of E1 intersection E2 is 10, and probability of E2 is 20, and probability of probability of E2 is 0.2, probability of E1 intersection E2 is 0.1, and probability of E1 is 0.3. So these things are already given from us from the question. Now it's asking about what is the probability that the person will fail in the English if he has already failed in English. So it means they are talking about probability of failing in English means E1, means happening of event E1 when E2 event has already occurred. So this thing is translated into this particular probability. He will fail in English means probability of failing in English, event of failing in English is denoted by E1, and event of failing in Hindi is denoted by E2. So it is exclusively given that he has already failed in Hindi. Then what is the probability that he will also fail in English? So in that case, E1 E1 probability of finding of E1 when E2 has already happened. So this particular thing can be written this way, and we know that this particular formula is E1 intersection E2 divided by this particular below side, which is probability of E2. This thing is also given as 0.1, and this particular thing is also given 0.2. So in that case, your probability comes to be 0.5. Okay. So these particular questions can be thought of questions of conditional probability, and this is how it will solve using the particular formula of conditional probability that you have. Okay, the main thing is about translating these things into the conditional probability, like understanding which event it is talking about, which event should be your first event, second event, and how the things is being translated into conditional probability. Like here it is written that he has, what is the probability that he will fail in English if he has failed in English. So I told he conditional probability is something when like a event occurs when particularly event, some particular event E1, E2, E3, E4 has already occurred. So when this particular type of things are being asked in the questions, it is a questions of conditional probability, and you have to use this particular formula. Okay, so already it is given that something has happened, and what is the probability of happening of something else, and this particular type of questions you will find the questions of conditional probability. Okay, any confusion, any questions, or is it clear? Okay, so the next thing is actually very much important. It's the concept from the total probability. Okay, so like before explaining the total probability, just let me explain you a diagram. So let's say this is your sample space. This is your entire sample space, and like let's say there are number of events E1, E2, E3, En. Okay, so let's say there are number of event. Okay, so there are number of event, and like this particular region is a region of E1, this particular region is E1 of E2, and this particular region, last one, is the region of En. Okay, so there are number of events, and S is something. This whole sample space is the S. Okay, whole everything is the S. Like this is saying that ki E1, E2, En be the n mutually exclusive and exhaustive event. So here you can see that every event is mutually exclusive and exhaustive, because if it would have not been mutually exclusive and exhaustive, then some event may be overlapping with some other. So it's the first condition with the total probability theorem, that the all the events should be mutually exclusive and exhaustive event. Okay, so mutually exclusive and exhaustive we already saw. It means if you take the union, you get the set S. If you take the intersection of everything, you will get null set. Means none of the elements are common. So same thing is being used here. You can see that any of the, if you take the event union of all the events, okay, so it is sample space S. Okay, and if you take intersection, nothing is common, because everything is originating from like it has on boundary, it has on its own area. Okay, on space. So it means that if these two conditions are satisfied, then we can talk about a total probability. So then what is the total probability theorem? So like this mutually exclusive event means any event you are talking about E1 intersection E2 dot En is equal to phi, and this particular condition can also be written as this way. So this way means Ei intersection Ej. It means if you are taking intersection of any two event, it is phi. Okay, any two event. So let's say you're talking about E1 and E1. If you take intersection of all those two events, it is a null set. And similarly for the other thing also, for I not equal to 0. I think if you are a mathematics student, I think you are already aware about this type of notation. So this type of notation is actually being used for translating, means writing a lot of conditions. So it means that for every I and j, I from 1 to n and j from 1 to n, every I and j, if I is not equal to j, in that case, if you take events in intersection of any event, you will get a null set. Maybe you are taking intersection E1 intersection En, or maybe you are taking E1 intersection E5, or E7 intersection E10. So in any particularly combinations of event, you are taking intersection, you will find a null set. Okay, and the second condition is if you are taking union of all the event. So this is actually the something similar to summation. Summation I from 1 to n means xi means x1, x2, x3 dot xn. So in this particular case, it is also true that union of I from 1 to n is ei is I from e1, e2, e3 dot even, and we are taking the union particularly thing. Okay, so this thing is similar to e1 union e2 union as n. Okay, so similarly, the overall thing is that if E1 and En are n mutually exclusive event represented by this condition and exhaustive event, in that particular case, probability of occurring of any particularly event E is actually equal to summation of I from 1 to n. Okay, all the events are actually being included here. Probability of EI and probability of happening of E when EI has occurred. Okay, so this particularly things written in the word can be difficult. So just let me include this way. So let's say this particularly E, this black region is the area of region of E. Okay, so you can see that when E is occurring, actually it's also being dependent on E1. It is also being dependent on E2, and similarly it is being covered by every event simultaneously. Okay, that's why when you are talking about occurrence of any event in this setup, the setup is you should have n number of event, n can be any number, and these events should be mutually exclusive and exhaustive event. In that particular case, if you're trying to find the probability of any event E, in that case you have to find, means this particular thing is being translated into summation of this particular product, which is probability of occurring of EI and probability of occurring of E when EI has already occurred. Okay, so this is how this setup is being demonstrated in the figure. There are n number of event, and in particular any event is occurring, it is being dependent on each and every event. So it should be covered by this event, and that's how this formula is being represented. It is being covered by each and every EI. You can see that here. Okay, so I think this will be more clear from our example, and if you have any questions in this particular theory or definitions, just let me know. Otherwise, we are going to see an example based on that. Simple thing, just n events are there, and all the events are mutually exclusive and exhaustive. And similar thing, if you're talking about probability of occurring of any event E, obviously it is being translated into the summation of this particular product, which is exclusively covering the all the covering of happening of E through all the events. Okay, through all the events. So E1 is occurring, it is also contribution in E. E2 is occurring, then it is also contribution in E, and similarly it has contribution in every event. Okay. So let me just explain the simple example. So the example is an urn. Urn means a bag contain two white and two black balls. Okay. So there is a two white and two black balls. A ball is drawn at random. A ball is picked at random. If it is a white ball, it is not replaced into urn. So let's say there are white ball and black ball. So if you just put out a black ball and it is turned out to be a white ball, so it is not returned into this particularly bag. It's not returned into that. Okay. But if it's a black ball, if it's a black ball, obviously it is being replaced by the ball of the same color. Okay, so let's say you just picked up, there are four balls, two white, two black. You picked a black ball. Okay, so it is a black ball, so you are now putting two balls, because one is the ball you picked up and one is the ball you are putting it with the replacement. So now there will be five balls, and two will be the white balls and three will be the black balls. Okay, so it means that it's talking about if it is a white ball, it is not being replaced into one. Otherwise, it is replaced along with the another ball of the same color. So if it's a black ball, it will be being replaced by the another black ball of the same color. The process is repeated. Find the probability that third ball drawn is the black. So it is talking about key first ball must have been drawn, it must have been something. Second ball is drawn, it must have been something. But just now focus on third ball, and what is the probability that the third ball is the black. Okay, third ball is the black. Okay, so if you're talking about third black, then we have to consider all the possibility of one and first and second ball. Okay, and this is fairly simple. Okay, so like of either first ball can be white, second ball can be white, first ball can be black, second ball can be white, and similarly all the possible combinations. So we are representing these all possible combination by E1, E2, E3, and E4. Okay. So E1 means either first ball is white and second ball is also white. E2 means first ball is white but second ball is black, and similarly E3 means first ball is black, second ball is white. Because in first two event any possible combinations must have been drawn. Okay, it would have been happened, this particular combination must have been wrong, or it would have been happened that this particular concept must have been wrong. So in this particular case, you need to encounter all the possible thing, and then you have to find the probability of your third row, which is a blackboard. Okay, so that's why we are just trying to encounter everything step by step. And if means black and black, so any combination, let's say this particular combination has been wrong, then what is the probability of black? So I told you that this is particularly the same setup of total probability. You have four events, one, two, three, four. 1, 2, 3, 4. Okay, okay, 1, 2, 3, 4. So this is, let's say, region of E1. This is region of E2. This is region of E3, and this is region of E4. Okay. In this particular case, any event is occurring. It means occurring also black ball in the third time. So it may happen that it have, even event have been occurred. Then what is the probability of occurrence of black hole? It may have been occurred that E2 event has been occurred, or it may happen that E3 event has been occurred. So we don't know about that. That's why this particular probability of drawing a black ball in the third times actually depends on each and every event. Okay, that's why we are just trying to find these things, and just trying to the finding the all the overall probability within the same thing. Okay, so in this case, probability of happening of event E1 is what? So E1 means first ball is also white, second ball is also white. So first ball is white means there are out of four balls, you are trying to draw a ball from four balls. It is 2 by 4. Obviously, you know this particular thing. Okay, so 2C1 by 4C1. So it will be equal to 2 by 4. Okay, and it's talking about black balls. Okay, so second chance also draw a white ball. So since you draw a white ball, you did not replace, because it's saying that it is not replaced when you are trying to draw a white ball. So in that case, in the second case, you will just have the three balls there, and out of three balls, only one white ball is there. Simple thing, 2 by 4 into 1 by 3. And similarly, this particular probability is probability of happening of white ball, and then probability of occurring of white ball when white ball has been drawn. Similarly, this E2 is the probability of occurring of white, and then probability of occurring of black when white ball has been drawn. So this particular thing is in this way, and this is calculated this way. So in this case, it is saying that the probability of occurring a white ball, obviously 2 by 4, and since its first ball was white, it was not replaced. But now, since you are drawing a black ball, the probability will be 2 by 3, because there are only three balls left and two balls is of black type. Okay. Similarly, for E3, it's saying that it's a black and white. So if you draw black ball in the first chance, it is sure that you have put that black and then along with the one another ball. So now in that case, you have five balls, out of which three are black and two are white. So this will be 2 by 5. And similarly, in that case, 3 by 5. So guys, is there any problem understanding this problem setup? Okay, so I told ki this thing is being translated into this particular thing, and this is why this particular thing is mutually exclusive and exhaustive event. So now we have to find our required probability, and required probability is probability of finding of B, and actually B is being dependent on everything. So just we need to write a formula of total probability, which is probability of occurring of event E1, then probability of occurring of a black ball when E1 has already occurred. So this particular thing is there. Probability of occurring of B2 and probability of occurring of event E2, probability of occurring of finding a black ball when E2 has already occurred. Similarly for E3 and similarly for E4. So this particular thing you need to calculate. Okay. So if event E1 has already occurred, then what is the probability of finding a black ball? Okay. So if E1 has already occurred, then in that case we are not having any white ball no more, because both the white ball has been drawn in the first two attempt. So we are just left with the black ball. In that case, drawing a black ball will have a 100% chance. So it's a one. And if event E2 has occurred, which is you have drawn a white ball and you have just drawn a black ball, so it is true that after you have drawn a black ball, you have put that ball in the bag along with another black ball. So now you have three black ball, and but you have only four balls in the total. Okay, because you have already removed the white ball. So in this case, it will be 3 by 4, and similarly for the other cases also. And just you use this formula, you put the everything like probability of B1 and 2, probability of working of B1 E1 is occurred, and similarly you get the this particular answer. So I think it's a fairly complicated problem, because a lot of things are being used here. But if you just think step by step, you will be able to solve this particular thing. So do you have any problem or doubts like solving these questions? Let me know. Guys, do you have any confusion or any thing? Anyone? Okay, so this particular thing that I am discussing, this particular thing is actually like obviously you can expect some easier questions in the exam, but the thing is that a lot of good questions is framed on the basis of conditional probability, total probability, and Bayes theorem, and everything is simple. Just try to like obviously just you just understand this particular setup. कि when particular event but occurring a particular event is being dependent on each and every possibilities. In that case, we are using total probability. Okay, and this case is exactly here. Whatever would have been the result of first two drawn, which is these four possibilities, the next draw actually depends on all these things. If it had been even, the third possibility would be different, and that's how we are encountering each and everything step by step. Okay, so in this point of time, you can use now we can use the total probability theorem, or total probability law to define the Bayes theorem. Okay, so like this particular Bayes theorem, before discussing, just like it's just the same thing, and just it's just the inverse of the same thing. Okay, so let's say this particular thing that I explained to you here. Okay, this is the E1 event. This is this is particularly same thing, and just say that this is En, this is E2. Okay, similar thing is there, and there is another event which is this particular thing. Okay, and in this case, we just we this is the region of your first another event E. Okay, this is the region of another event E. Okay, now we are just now trying to find the probability of E which is being dependent on E1, E2, En, and we're just trying to include everything in the probability. But probability of happening of is the same. Okay, it's a fine, but now what happens when you are actually interested in, okay, what is the probability of happening of means e1 when e has already occurred? It means that if let's say e has occurred and you know the probability of e using this formula, then what is the chance that it is being included from probability e1? So what is the probability of occurring of e1? So it means that just you can think of this way that there are a lot of probabilities there. Okay, and each of these events have some contribution in e. So if e has already occurred, then we are trying to find what is the probability that e has occurred due to e1. Okay, so this is particular thing that we have trying to find, and you can just simply generalize this thing by ei, and it means that what is the probability of occurring of ei when e has already occurred. So this is simply means that if probability of e is happening, then what is the probability this particularly event I is has it has happened due to this particular event I. Okay, so this is how the Bayes theorem is computed, and Bayes theorem can be understood. Okay, so let me discuss a problem, and then you can understand it. So the thing is that a bag A contains two white and three red balls, and a bag B contains four white and five black balls. Just let me see how. Just let me explain you how this particular thing is coming. So there's a black A and there's a bag B. Okay, so this thing has two white and three red, and this particular bag B has four white and five red. Okay, a ball is drawn at random from one of the bags. So it's saying that a ball is drawn from random at one of the bags. So it may be either A or it may be B, and it is found to be red. Okay, we also found that the ball is the red. What is the probability that the ball is drawn from bag B? It's saying that okay, there are two events. Okay, just divide this thing by this way. Okay, so this is a bag A and this is bag B. Okay, so it means that a ball is drawn, it is found to be red. Then what is the probability that this particular thing is coming from bag B? So it means that what is the probability that any particular event is happening? If it has happened, what is the probability it is happening due to EI, due to event EI? That's what we are trying to encounter here. Okay, simple thing. We just now can calculate the probability of E, and at this point in time, we are just trying to find out what is the probability that if E has occurred, then it is occurring due to E1, or maybe it is occurring due to E3, or maybe it is occurring due to EN, and there must have been some probability associated with it. So maybe 0.2, 0.9, anything that you'll find out. Okay, so to find this particular thing, the simple thing is that if an event E can occur only with one of the events in mutually exclusive industry event, then the Bayes theorem is probability of EI given E. Okay, so this means that probability of occurring of EI when E has already occurred. It means that, or same thing we can say that probability of occurring of E means probability of E is already happened. Then what is the contribution of EI? What is the probability it has occurred due to EI? Okay, just like we saw it here, na, the red ball is already drawn. So probability of drawing the red ball, probability of drawing a red ball is your E. Okay, so it's talking about what is the probability it was drawn from bag A. So like here we have just two event, but in generalized you can select what is the probability of happening of that event E due to EI. So this particular thing is being translated into this way because you just reverse this particular thing and you have this particular thing because you already know this thing. And this means probability of EI into probability of E given EI and all the total probability of this probability. This is the total probability theorem. Okay, total probability theorem it is. So it means that just you need to find out total probability and probability of occurring of EI for which it's talking about into probability of occurring of E given EI and just divide this thing by the total probability law. Okay, so same thing is here also. Just you can see that we are just adding everything on the total probability law, and you can just see that this is actually a weightage of event EI. So, are you all aware about the weighted mean? Means any on one of you aware about the weighted mean? Anyone? Guys, are any one of you aware about the weighted mean or not? So, weighted means like every thing actually have some weight, right? And in this case you can also see that we are actually dividing this whole thing and we are just in particular we are trying to find out the weight of this particular thing, this particularly EI. So this is a high level idea of how you can understand this total probability theorem, because I told you that you are just trying to find out the contribution of that particular thing, maybe EI event EI maybe E1 E2, and you are trying to find the contribution of that particular thing when E has already happened. Okay, so this thing overall actually calculates the weight of this particular thing. Or if you don't understand this particular thing, just remember how you have to calculate it, and that is also fair that you can solve each and every questions. But if you just understand this particular thing, obviously it's good. Okay, so trying to find out this particularly question, the simple thing is that you have to identify your E1, E2, and E. So there are some contribution from E1 and E2, and there is some event E. So if it has been in three part, maybe we need to define E1, E2, E3, E4, and whatever the part is. But when you define all those things only, then you can just calculate this probability. So similarly, the thing is that E1 and E2, and it's saying that the bag A contains this particular balls. Then we define E1 as to be events of balls being drawn from A. So like it's saying that either ball will be drawn from A or ball will be drawn from B. So E1 is the our event of drawing a ball from A, and E2 is the event of drawing a ball from B, and E is the event of drawing a red ball. Okay. So if you're trying to find the probability of E, which is probability of drawing a red ball, it means that you just can use the total probability law, which is probability of occurring of E1 and then probability of occurring of E when E1 has already occurred, plus probability of occurring of E2, and then probability of occurring of E when E2 has already occurred. In that this case, this thing is simple. Probability of occurring of E1 means what is the chance that you get to select ball from bag A. So there are two bags and they are equally likely to be selected. So because there is no any bias, there is no any setup involved. So setup means you are trying to introduce some bias, you are trying to cheat with the experiment. So this is not involved. Obviously you have two bag A and B, so any one can be drawn at random. So probability of occurring of E1 is 1 by 2, and probability of occurring, sorry, multiplication, probability of occurring of E when E1 is occurred. So let's say now we have selected bag A, then what is the probability of drawing a red ball? Obviously drawing a red ball means out of 5 balls you have to draw a red ball, so it's 3 by 5. Okay, so everything we have introduced here in this particular thing, the probability of E1 and E2 is 1 by 2, because you can draw any bag at random, A or B. You can draw any bag at random, any bag at random, and obviously there is 50% chance of being selected A, 50% chance of being selected B. So it would have been three bag. It would have been 1 by 3 chance for each and every bag. Okay. Now it's saying that the probability of occurring of E when E1 has already occurred is this particular thing, because obviously if you select bag A, in that case you can select ball red by 3 out of 5 choices. And if you have been selected ball bag B, in that case it would have been 5 red ball out of total 9 balls. Okay, so it would be 5 by 9. And just you need to use this particularly formula of this particular thing, because we are actually interested in finding the probability that it was drawn from bag B. Means bag B is being represented by E2 here. This particular two event, that event of ball being drawn random from bag B. Okay, so this particular thing is being represented by E2. So we are trying to find probability of E2 when E has already occurred, and this particular thing using the total base theorem is actually being translated into this way. Just reverse this particular thing, and e2 in the beginning, and just divide it by the summation, overall summation or total probability. So this is the total probability, same formula of total probability, and that we are calculating here. So 1 by 2 into 3 by 5 plus 1 by 2 into 5 by 9. Okay, and when you will calculate this particular thing, you will get your particular answer. So this is how you solve questions using the Bayes theorem. So, guys, is it clear like how Bayes theorem is being used to find the this particularly probability when some event has already occurred, and we're already trying to find a contribution of E2. Okay, like it may exclusively given in the questions that find the like there is not been given to find the contribution of E2 or find the contribution at E1, but it may be given the exact what is the contribution of E1 or maybe En when you are trying to find the probability of E. Okay, so this thing can be given in the question. Okay, so exclusively there is something called you may find also contribution of two events simultaneously. So like you are interested in finding probability of E1 union E2 when E has already occurred. Okay, so these things you can also find, and in the next class we will see this particular thing and some more questions on the probability, and we also touch some topic of the random variable. So till now you can solve a lot of questions from the Bayes theorem, total probability, and in next class also we like probability, math, these are all the topics of problem and solution, like questions, and like much more and more questions solved, the more concept you will get clear, and you will just remember how to use this particular thing. So we'll see some more concept from the questions from the probability in the next class, especially from Bayes theorem and this total probability theorem. And the thing is that the same thing, just need to understand that the overall sample space is being divided into n event, and any particular event is occurring and it has contribution in each and every event. Okay, so that's how you can just think this as a whole. Okay, so do you have any questions or any doubt? Just let me know.